Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your team has a model deployed to a Vertex AI endpoint. You have created a Vertex AI pipeline that automates the model training process and is triggered by a cloud function. You need to prioritize keeping the model up to date, but also minimize retraining costs. How should you configure retraining? The options are: Option A, configure pub/sub to call the cloud function when a sufficient amount of new data becomes available. Option B, configure a cloud scheduler job that calls the cloud function at a predetermined frequency that fits your team's budget. Option C, enable model monitoring on the Vertex AI endpoint. Configure pub/sub to call the cloud function when anomalies are detected. Option D, enable model monitoring on the Vertex AI endpoint. Configure pub/sub to call the cloud function when feature drift is detected.
To arrive at the correct answer, we focus on the keywords: model deployed to a Vertex AI endpoint, triggered by a cloud function, prioritize keeping the model up to date, minimize retraining costs.
The correct answer is option D, enable model monitoring on the Vertex AI endpoint. Configure pub/sub to call the cloud function when feature drift is detected.
Why is this correct? D, enable model monitoring to detect feature drift, indicating the model's performance may degrade due to changing data distributions. Triggering retraining only upon drift keeps the model up to date when needed, minimizing unnecessary retraining costs compared to fixed schedules. Why are the others incorrect? A, triggering retraining solely based on new data volume ignores data distribution changes. This leads to unnecessary retraining if data hasn't drifted, failing to minimize costs. B, scheduled retraining runs regardless of data distribution changes, leading to wasted budget on unnecessary retraining or delayed updates if model drift occurs between scheduled runs. Why are the others incorrect? C, anomalies can include isolated outliers or errors that don't necessitate retraining. Feature drift specifically indicates shifts in data distribution, making it the precise, cost-effective trigger for model retraining.
You work for a retail company. You have created a Vertex AI forecast model that produces monthly item sales predictions. You want to quickly create a report that will help to explain how the model calculates the predictions. You have 1 month of recent actual sales data that was not included in the training dataset. How should you generate data for your report? The options are: Option A, create a batch prediction job by using the actual sales data. Compare the predictions to the actuals in the report. Option B, create a batch prediction job by using the actual sales data, and configure the job settings to generate feature attributions. Compare the results in the report. Option C, generate counterfactual examples by using the actual sales data. Create a batch prediction job using the actual sales data and the counterfactual examples. Compare the results in the report. Option D, train another model by using the same training dataset as the original and exclude some columns. Using the actual sales data, create one batch prediction job by using the new model and another one with the original model. Compare the two sets of predictions in the report.
To arrive at the correct answer, we focus on the keywords: Vertex AI forecast model, explain how the model calculates the predictions, actual sales data.
The correct answer is option B, create a batch prediction job by using the actual sales data, and configure the job settings to generate feature attributions. Compare the results in the report.
Why is this correct? B, Vertex AI explainable AI provides feature attributions that explain how each feature contributes to a model's prediction. enabling this feature in a batch prediction job quickly and directly provides the necessary explanatory data. Why are the others incorrect? A. Comparing predictions against actuals only evaluates model accuracy and performance. It does not provide any insight into how the model calculates its predictions. C. Generating counterfactual examples is not the standard approach for explaining Vertex AI forecasting models. Feature attributions are the correct built-in mechanism for this purpose. D. Retraining a model without certain columns is an inefficient, manual ablation study. It takes too much time and effort when Vertex AI already provides built-in feature attributions.
You recently deployed a scikit-learn model to a Vertex AI endpoint. You are now testing the model on live production traffic. While monitoring the endpoint, you discover twice as many requests per hour than expected throughout the day. You want the endpoint to efficiently scale when the demand increases in the future to prevent users from experiencing high latency. What should you do? The options are: Option A, deploy 2 models to the same endpoint and distribute requests among them evenly. Option B, configure an appropriate min replica count value based on expected baseline traffic. Option C, set the target utilization percentage in the autoscale metric specs configuration to a higher value. Option D, change the model's machine type to one that utilizes GPUs.
To arrive at the correct answer, we focus on the keywords: Vertex AI endpoint, twice as many requests per hour than expected, efficiently scale when the demand increases, prevent users from experiencing high latency.
The correct answer is option B, configure an appropriate min replica count value based on expected baseline traffic.
Why is this correct? B. Configuring an appropriate min replica count based on the newly discovered baseline traffic ensures enough instances are always running. This allows Vertex AI to scale more efficiently from a sufficient baseline when demand spikes, preventing high latency. Why are the others incorrect? A. Distributing requests between 2 models on the same endpoint is a technique for A/B testing or canary deployments, not a mechanism for dynamically scaling to handle increased traffic. C. Increasing the target utilization percentage delays the autoscaling process, as utilization must reach a higher threshold before new replicas are added. This increases the risk of high latency during traffic spikes. D. Scikit-learn models typically rely on CPUs and do not benefit significantly from GPUs. Changing the machine type does not address the fundamental need for an efficient autoscaling configuration.
You built and manage a production system that is responsible for predicting sales numbers. Model accuracy is crucial, because the production model is required to keep up with market changes. Since being deployed to production, the model hasn't changed, however the accuracy of the model has steadily deteriorated. What issue is most likely causing the steady decline in model accuracy? The options are: Option A, poor data quality. Option B, lack of model retraining. Option C, too few layers in the model for capturing information. Option D, incorrect data split ratio during model training, evaluation, validation, and test.
To arrive at the correct answer, we focus on the keywords: keep up with market changes, model hasn't changed, accuracy of the model has steadily deteriorated.
The correct answer is option B, lack of model retraining.
Why is this correct? B. Lack of model retraining is the most likely cause. As market changes occur, data distribution shifts, concept drift. Because the model hasn't changed post-deployment, it fails to adapt to these new patterns, causing its accuracy to steadily decline over time. Why are the others incorrect? A. Poor data quality typically results in immediate poor performance or erratic fluctuations, rather than a steady, progressive deterioration in accuracy after deployment. C. Too few layers leads to underfitting, causing poor accuracy immediately upon deployment, not a gradual, steady decline over time while the model remains static. D. An incorrect data split ratio affects the initial model evaluation and training metrics but would not cause a continuous, steady decline in accuracy post-deployment.
You are designing an ML recommendation model for shoppers on your company's e-commerce website. You will use Recommendations AI to build, test, and deploy your system. How should you develop recommendations that increase revenue while following best practices? The options are: Option A, use the other products you may like recommendation type to increase the click-through rate. Option B, use the frequently bought together recommendation type to increase the shopping cart size for each order. Option C, import your user events and then your product catalog to make sure you have the highest quality event stream. Option D, because it will take time to collect and record product data, use placeholder values for the product catalog to test the viability of the model.
To arrive at the correct answer, we focus on the keywords, Recommendations AI, increase revenue, best practices.
The correct answer is option B, use the frequently bought together recommendation type to increase the shopping cart size for each order.
Why is this correct? B. The frequently bought together recommendation type is specifically designed to increase shopping cart size and average order value, directly aligning with the goal to increase revenue using Recommendations AI best practices. Why are the others incorrect? A. The other products you may like recommendation type primarily optimizes for click-through rate and discovery, which does not as directly maximize revenue per order. C. According to Recommendations AI best practices, you must import your product catalog before importing user events so that events can be correctly associated with valid products. D. Using placeholder values is an anti-pattern. Recommendations AI requires real product catalog metadata to build meaningful representations and effectively test model viability.
You work at a gaming startup that has several terabytes of structured data in cloud storage. This data includes gameplay time data, user metadata, and game metadata. You want to build a model that recommends new games to users that requires the least amount of coding. What should you do? The options are: Option A, load the data in BigQuery. Use BigQuery ML to train an autoencoder model. Option B, load the data in BigQuery. Use BigQuery ML to train a matrix factorization model. Option C, read data to a Vertex AI workbench notebook. Use TensorFlow to train a two-tower model. Option D, read data to a Vertex AI workbench notebook. Use TensorFlow to train a matrix factorization model.
To arrive at the correct answer, we focus on the keywords, structured data, recommends new games, least amount of coding.
The correct answer is option B, load the data in BigQuery. Use BigQuery ML to train a matrix factorization model.
Why is this correct? B. BigQuery ML allows training models on structured data using SQL, requiring the least amount of coding. Matrix factorization is the standard built-in algorithm in BigQuery ML specifically designed for recommendation systems. Why are the others incorrect? A. While BigQuery ML minimizes coding, autoencoders are typically used for anomaly detection and dimensionality reduction, not for building recommendation engines. C. Using TensorFlow and Vertex AI Workbench to train a two-tower model requires writing extensive custom code, contradicting the requirement for the least amount of coding. D. Building a matrix factorization model using TensorFlow involves significantly more custom code and effort compared to leveraging BigQuery ML's built-in capabilities.
You work as an ML engineer at a social media company, and you are developing a visual filter for users' profile photos. This requires you to train an ML model to detect bounding boxes around human faces. You want to use this filter in your company's iOS-based mobile phone application. You want to minimize code development and want the model to be optimized for inference on mobile phones. What should you do? The options are: Option A, train a model using AutoML Vision and use the Export for Core ML option. Option B, train a model using AutoML Vision and use the Export for Coral option. Option C, train a model using AutoML Vision and use the Export for TensorFlow.js option. Option D, train a custom TensorFlow model and convert it to TensorFlow Lite, TF Lite.
To arrive at the correct answer, we focus on the keywords: iOS-based mobile phone application, minimize code development, optimized for inference on mobile phones.
The correct answer is option A, train a model using AutoML Vision and use the Export for Core ML option.
Why is this correct? A. Core ML is Apple's native machine learning framework for iOS applications, and AutoML Vision minimizes code development while generating models optimized for edge device inference. Why are the others incorrect? B. The Export for Coral option is specifically designed for Google Coral Edge TPU hardware devices, not for iOS mobile phone applications. C. TensorFlow.js is intended for running machine learning models in web browsers or Node.js environments, not for optimized native iOS applications. D. Building and training a custom TensorFlow model requires significant programming effort, violating the primary requirement to minimize code development.
Refer to the attached Picture 1, reference exhibit. You trained a text classification model. You have the following signature DEFS. You started a TensorFlow serving component server and tried to send an HTTP request to get a prediction using headers equals content type application/JSON, JSON_response equals requests.post, http://localhost 8501/v1/models/text_model, predict, data equals data, headers equals headers. What is the correct way to write the predict request? The options are option A, data equals JSON.dumps, signature_name, sevang_default, instances, A, B, C, CD. Option B, data equals JSON.dumps, signature_name, serving_default, instances, A, B, C, D, E, F. Option C, data equals JSON.dumps, signature_name, serving_default, instances, A, B, C, D, E, F. Option D, data equals JSON.dumps, signature_name, serving_default, instances, A, B, C, D, E, F.
To arrive at the correct answer, we focus on the keywords: signature DFS, predict request.
The correct answer is option D, data equals JSON.dumps, signature_name, serving_default, instances, A, B, C, D, E, F.
Why is this correct? D. The signature def shown in the exhibit specifies the input tensor shape as -1, 2. Option D correctly provides an array of instances with a shape of 3, 2, matching the required inner dimension of 2. Why are the others incorrect? A. The instances list has a shape of 1, 3, which does not match the required -1, 2 shape. Additionally, the signature_name is incorrectly spelled as sevang_default. B. The data provided has a shape of 1, 6, which violates the required input shape of -1, 2, defined in the signature def. C. The instances array has a shape of 2, 3. This is incorrect because the signature def explicitly requires the inner dimension to be exactly 2.
You are training an ML model on a large dataset. You are using a TPU to accelerate the training process. You notice that the training process is taking longer than expected. You discover that the TPU is not reaching its full capacity. What should you do? The options are: option A, increase the learning rate. Option B, increase the number of epochs. Option C, decrease the learning rate. Option D, increase the batch size.
To arrive at the correct answer, we focus on the keywords: large dataset, TPU, training process is taking longer than expected, TPU is not reaching its full capacity.
The correct answer is option D, increase the batch size.
Why is this correct? D. Increasing the batch size allows more data to be processed in parallel during each step, effectively utilizing the TPU's massive matrix multiplication units and improving overall hardware utilization. Why are the others incorrect? A. Increasing the learning rate affects model convergence and optimization dynamics, not hardware utilization, so it will not help the TPU reach full capacity. B. Increasing the number of epochs will only make the total training time longer without improving the TPU's hardware utilization per training step. C. Decreasing the learning rate affects the optimization process and convergence speed, not hardware utilization, and will not address the TPU's lack of full capacity.
You are deploying a new version of a model to a production Vertex AI endpoint that is serving traffic. You plan to direct all user traffic to the new model. You need to deploy the model with minimal disruption to your application. What should you do? The options are: Option A, 1. Create a new endpoint. 2. Create a new model. Set it as the default version. Upload the model to Vertex AI Model Registry. 3. Deploy the new model to the new endpoint. 4. Update Cloud DNS to point to the new endpoint. Option B, 1. Create a new endpoint. 2. Create a new model. Set the parent model parameter to the model ID of the currently deployed model and set it as the default version. Upload the model to Vertex AI Model Registry. 3. Deploy the new model to the new endpoint and set the new model to 100% of the traffic. Option C, 1. Create a new model. Set the parent model parameter to the model ID of the currently deployed model. Upload the model to Vertex AI Model Registry. 2. Deploy the new model to the existing endpoint and set the new model to 100% of the traffic. Option D, 1. Create a new model. Set it as the default version. Upload the model to Vertex AI Model Registry. 2. Deploy the new model to the existing endpoint.
To arrive at the correct answer, we focus on the keywords: new version of a model, Vertex AI endpoint, serving traffic, direct all user traffic to the new model, minimal disruption.
The correct answer is option C, 1. Create a new model. Set the parent model parameter to the model ID of the currently deployed model. Upload the model to Vertex AI Model Registry. 2. Deploy the new model to the existing endpoint and set the new model to 100% of the traffic.
Why is this correct? C. Correct. Uploading as a new version using parent model and deploying to the existing endpoint with a 100% traffic split ensures a seamless transition with minimal disruption. Why are the others incorrect? A. Incorrect. Creating a new endpoint and updating DNS introduces unnecessary complexity and potential DNS propagation delays, which violates the requirement for minimal disruption. B. Incorrect. Creating a new endpoint is unnecessary when deploying a new version. Vertex AI supports traffic splitting on existing endpoints to minimize disruption. D. Incorrect. This option does not explicitly configure the traffic split to 100% for the new model on the existing endpoint, which is required by the scenario.
You have trained a model by using data that was pre-processed in a batch Dataflow pipeline. Your use case requires real-time inference. You want to ensure that the data pre-processing logic is applied consistently between training and serving. What should you do? The options are: Option A, perform data validation to ensure that the input data to the pipeline is the same format as the input data to the endpoint. Option B, refactor the transformation code in the batch data pipeline so that it can be used outside of the pipeline. Use the same code in the endpoint. Option C, refactor the transformation code in the batch data pipeline so that it can be used outside of the pipeline. Share this code with the end users of the endpoint. Option D, batch the real-time requests by using a time window and then use the Dataflow pipeline to pre-process the batched requests. Send the pre-processed requests to the endpoint.
To arrive at the correct answer, we focus on the keywords: batch data flow pipeline, real-time inference, ensure that the data pre-processing logic is applied consistently between training and serving.
The correct answer is option B, refactor the transformation code in the batch data pipeline so that it can be used outside of the pipeline. use the same code in the endpoint.
Why is this correct? B. Refactoring the transformation logic into a shared module ensures the exact same pre-processing steps are applied during batch training in Dataflow and real-time serving in the endpoint, effectively preventing training serving skew. Why are the others incorrect? A. Data validation only checks input data schemas and formats. It does not actually perform the required data pre-processing or transformations needed for inference. C. Offloading pre-processing logic to end users forces clients to implement the transformations, which introduces complexity, security risks, and potential inconsistencies across different client applications. D. Batching requests using a time window introduces significant latency, which violates the strict requirement for real-time inference.
You are analyzing customer data for a healthcare organization that is stored in cloud storage. The data contains personally identifiable information, PII. You need to perform data exploration and pre-processing while ensuring the security and privacy of sensitive fields. What should you do? The options are: Option A, use the Cloud Data Loss Prevention (DLP) API to de-identify the PII before performing data exploration and pre-processing. Option B, use Customer Managed Encryption Keys (CMEK) to encrypt the PII data at rest and decrypt the PII data during data exploration and pre-processing. Option C, use a VM inside a VPC service controls security perimeter to perform data exploration and pre-processing. Option D, use Google Managed Encryption Keys to encrypt the PII data at rest and decrypt the PII data during data exploration and pre-processing.
To arrive at the correct answer, we focus on the keywords: personally identifiable information, PII, perform data exploration and pre-processing, ensuring the security and privacy of sensitive fields.
The correct answer is option A, use the Cloud Data Loss Prevention (DLP) API to de-identify the PII before performing data exploration and pre-processing.
Why is this correct? A. The Cloud Data Loss Prevention (DLP) API can discover, classify, and de-identify sensitive data like PII. De-identifying data before exploration ensures privacy while still allowing necessary analysis. Why are the others incorrect? B. While Customer Managed Encryption Keys (CMEK) protect data at rest, decrypting it for exploration exposes raw PII to the analyst, failing to ensure the privacy of sensitive fields. C. A VPC service controls perimeter protects against data exfiltration but does not mask or de-identify PII. The analyst would still have access to raw sensitive data during exploration. D. Google Managed Encryption protects data at rest, but decrypting it during exploration still exposes raw PII to the user analyzing the data, failing to ensure privacy.
You work for a telecommunications company. You're building a model to predict which customers may fail to pay their next phone bill. The purpose of this model is to proactively offer at-risk customers assistance such as service discounts and bill deadline extensions. The data is stored in BigQuery and the predictive features that are available for model training include customer_ID age salary, measured in local currency, sex average bill value, measured in local currency, number of phone calls in the last month, integer, average duration of phone calls, measured in minutes. You need to investigate and mitigate potential bias against disadvantaged groups, while preserving model accuracy. What should you do? The options are: Option A, determine whether there is a meaningful correlation between the sensitive features and the other features. Train a BigQuery ML boosted trees classification model and exclude the sensitive features and any meaningfully correlated features. Option B, train a BigQuery ML boosted trees classification model with all features. Use the ml.global_explain method to calculate the global attribution values for each feature of the model. If the feature importance value for any of the sensitive features exceeds a threshold, discard the model and train without this feature. And the remaining options are: Option C, train a BigQuery ML boosted trees classification model with all features. Use the ml.explain_predict method to calculate the attribution values for each feature for each customer in a test set. If for any individual customer, the importance value for any feature exceeds a predefined threshold, discard the model and train the model again without this feature. Option D. Define a fairness metric that is represented by accuracy across the sensitive features. Train a BigQuery ML boosted trees classification model with all features. Use the trained model to make predictions on a test set. Join the data back with the sensitive features, and calculate a fairness metric to investigate whether it meets your requirements.
To arrive at the correct answer, we focus on the keywords, investigate and mitigate potential bias against disadvantaged groups, while preserving model accuracy.
View the options on screen. The correct answer is option D. Define a fairness metric that is represented by accuracy across the sensitive features. Train a BigQuery ML boosted trees classification model with all features. Use the trained model to make predictions on a test set. Join the data back with the sensitive features, and calculate a fairness metric to investigate whether it meets your requirements.
Why is this correct? D. Keeping sensitive features allows the model to learn effectively while you explicitly evaluate fairness by measuring accuracy metrics across demographic groups. This investigates bias directly without discarding features. Why are the others incorrect? A. Excluding sensitive features, fairness through unawareness, is flawed because proxy features can still introduce bias, and removing features reduces overall model accuracy. B. Removing a sensitive feature based on global attribution values doesn't guarantee fairness due to correlated proxy features and can unnecessarily lower the model's accuracy. C. Discarding features based on local attribution values, ml.explain_predict, for individual predictions is an impractical and ineffective way to address group-level bias.
You have a custom job that runs on Vertex AI on a weekly basis. The job is implemented using a proprietary ML workflow that produces the datasets, models, and custom artifacts, and sends them to a cloud storage bucket. Many different versions of the datasets and models were created. Due to compliance requirements, your company needs to track which model was used for making a particular prediction, and needs access to the artifacts for each model. How should you configure your workflows to meet these requirements? The options are: Option A, use the Vertex AI metadata API inside the custom job to create context, execution, and artifacts for each model, and use events to link them together. Option B, create a Vertex AI experiment and enable autologging inside the custom job. Option C, configure a TensorFlow extended TFX ML metadata database and use the ML metadata API. Option D, register each model in Vertex AI Model Registry, and use model labels to store the related dataset and model information.
To arrive at the correct answer, we focus on the keywords, custom job, proprietary ML workflow, track which model was used, access to the artifacts for each model.
The correct answer is option A. Use the Vertex AI metadata API inside the custom job to create context, execution, and artifacts for each model, and use events to link them together.
Why is this correct? A. The Vertex AI metadata API natively tracks metadata and lineage for custom ML workflows. By explicitly defining contexts, executions, and artifacts, and linking them with events, it fulfills complex compliance and auditing requirements without managing additional infrastructure. Why are the others incorrect? B. Vertex AI experiments autologging is designed primarily for tracking hyperparameters and metrics during training, not for recording complex lineage of custom artifacts produced by proprietary workflows. C. Configuring a standalone TFX ML metadata database requires managing extra infrastructure. Vertex AI metadata is a fully managed service that provides the same capabilities more efficiently. Why are the others incorrect? D. While the model registry organizes models, using basic model labels to store complex lineage information in artifact locations is an anti-pattern and lacks the required structural tracking.
You work for an online retailer. Your company has a few thousand short lifecycle products. Your company has 5 years of sales data stored in BigQuery. You have been asked to build a model that will make monthly sales predictions for each product. You want to use a solution that can be implemented quickly with minimal effort. What should you do? The options are: Option A, use Profit on Vertex AI training to build a custom model. Option B, use Vertex AI Forecast to build a NN-based model. Option C, use BigQuery ML to build a statistical ARIMA_plus model. Option D, use TensorFlow on Vertex AI training to build a custom model.
To arrive at the correct answer, we focus on the keywords: data stored in BigQuery, monthly sales predictions, implemented quickly with minimal effort.
The correct answer is option C, use BigQuery ML to build a statistical ARIMA_plus model.
Why is this correct? C. BigQuery ML allows you to train an ARIMA_plus time series model directly where the data resides using standard SQL. This avoids data movement and custom coding, perfectly satisfying the requirement to implement quickly with minimal effort. Why are the others incorrect? A. Building a custom profit model on Vertex AI training requires writing custom code and moving data out of BigQuery, contradicting the minimal effort requirement. B. While Vertex AI Forecast is powerful for time series forecasting, setting up and training a neural network model requires more overhead and effort than using BigQuery ML directly. D. Creating a custom TensorFlow model on Vertex AI training demands significant development time, coding, and infrastructure management, which does not meet the minimal effort constraint.